Hey there, welcome. Today, we are diving into a hidden force that is literally all around you, every single second of every day. It's what warms you up, it's what cools you down, and it is happening right now, whether you can see it or not. So, let's get into it. Okay, so we've all felt this, right? You step outside on a sunny day, and somehow the color of your short completely dictates how comfortable you are. It's just one of those facts of life. But have you ever really stopped to ask why? What is actually going on there? Well, the answer isn't just about color. It's about a kind of invisible energy, a constant glow that connects pretty much everything in the universe. And trust me, once you understand what it is, you will start seeing its effects absolutely everywhere. All right, let's kick things off with a concept that's, well, it's a little bit mind-bending. Everything, and I mean everything, is glowing. All the time. That's right. You sitting there right now are glowing. The desk you're at is glowing. The earth itself is glowing. The stars are glowing. Basically, if an object has any temperature above absolute zero, it is constantly putting out energy. We just can't see with our eyes because it's not in the visible light spectrum. Now, this invisible glow has a scientific name, of course. It's called thermal radiation. You can think of it as heat traveling in the form of invisible infrared waves. It's one of the most fundamental ways that energy gets around in the universe. Now, here's the thing that makes thermal radiation a real superstar. It has a kind of superpower that other forms of heat transfer, well, they can only dream of having it. I mean, just think about it for a second. The sun is millions and millions of kilometers away, and between us and it is the freezing cold, empty vacuum of space. There's no air, no water, nothing solid to carry that heat. So how in the world does its warmth get here? Well, other ways heat gets around, like conduction and convection, they need stuff to travel through. Think of heat moving up the handle of a hot pan or circulating in boiling water. But thermal radiation, it's different. It doesn't need anything. It just beams directly across the void. And that's exactly how we feel the warmth of the sun on our face. So, we've got this invisible glow beaming through space. That's pretty cool. But how does that solve our t-shirt mystery? Well, it all comes down to how different surfaces react when this radiation actually hits them. This little table right here, this is basically our cheat sheet for the whole thing. It lays out the rules of the game. Surfaces can absorb radiation, they can emit it, or they can reflect it. And as you can see, the color and the texture, they make all the difference. And here it is, the key to the puzzle. That black t-shirt you're wearing has a surface that's fantastic at absorbing thermal radiation. So when sunlight, which is packed with this radiation, hits it, the shirt just soaks it all up like a sponge, turning it into heat. And that's exactly why you feel so much hotter. The white t-shirt, on the other hand, does the complete opposite. Its surface is a great reflector, so it acts like a tiny mirror for all that invisible heat, just bouncing most of the sun's radiation away before it ever has a chance to be absorbed. It's why it stays so much cooler to the touch. But wait, there's a fascinating twist to all this. That same black t-shirt that gets hot so incredibly fast, it also cools down really fast. It turns out that good absorbers are also really good emitters. So, a hot black object will radiate its own heat away much more effectively than a hot, shiny one will. It's a two-way street. So why does any of this matter? Because once you understand these rules, you can start using them. This invisible glow becomes a tool, something you can actually use to control the temperature of the world around you. And we see these principles in action everywhere. Ever wonder why the inside of a thermos is so shiny? It's reflecting the heat from your coffee right back into the liquid to keep it hot. That emergency space blanket, same idea. It's reflecting your own body heat back to you. And what about those black, dull cooling fins on a computer or a stereo? They're designed to be great emitters, to radiate heat away as fast as possible. This is even why we paint houses white in hot climates and darker colors in cold ones. It's just smart physics. So, that invisible glow, maybe it's not so invisible anymore. From the shirt you decide to wear to the way we keep our gadgets cool, thermal radiation is a major player in our world. You've just been handed the instruction manual for one of the fundamental forces of the universe. The only question left is, how are you going to use it?